Hi, it's time for another math easy solution. We're going to discuss another linear approximation video, and I'll look at basically an example on differentials notation. These are the notes from my earlier video that I went over differentials notation. So if you haven't seen it, make sure to watch that in the video links below. Basically, I explained how to write linear approximation in terms of dx, dy, or differential notation, or Leibniz notation, and showed that basically dy is just a rise of this tangent line that's tangent to this f of x function, and delta y is just basically the rise of this f of x function. And to help illustrate this, I'm going to go over this example, which basically states compare the values of delta y and dy of the following function. And this is the function right here, y equals f of x and equals to x cubed plus x squared minus 2x plus 1 right here. And it's from these range when x changes from 2 to 2.05 and from 2 to 2.01 right here. So this is basically, in this case right here, our delta x is just basically equal to, well, it's also equal to dx. Delta x and dx are the same, like I explained in my last video. Delta x equals dx right here. And in case of part A right here, this delta x, you're just changing it by 0.05, and for this one right here, our dx is equal to 0.01. So they're saying part A, you're gonna have 0.05 delta x, and then you're gonna get a smaller one for dx. And now just compare these two values right here. Let's just solve first. First for part A, so we know that dx is equal to 0.05. So we gotta find delta y right here, and delta y, this is just a difference basically of the f of x function at 2.05 and then subtracted by 2. So this equals 2f of 2.05 minus f of 2, because remember, this is going to be the difference of these two right here. So this is f of x plus delta x minus f of x, and that's just this difference right here. So we could just subtract that. Well, if you plug this into the calculator, we get, well, f of 2.05 is equal to, so yeah, for f of 2.05, just plug that in. It's going to be 2.05 to the power of 3 plus 2.05 to the power of 2 minus 2 times 2.05 plus 1. Plug this into the calculator, we will get 9.7176. So now if we plug in f of 2 right here, we'll get basically 2 cubed, yeah, plus 2 squared minus 2 times 2 plus 1. And you can plug this in a calculator, or you could solve it for yourself. 2, the cube's going to be 8 plus 4 right here minus 4 plus 1. The 4's will cancel, so we'll have 8 plus 1, that equals to 9 right here. So now delta y is just going to be equal to 9.7176 minus this 9. Now plug this in. This will just get now 0.7176. So that's this delta y right here. Now if we want to solve for dy, well, we know dy is equal to f prime of x dx, and in this case we know that basically x is equal to 2, and our d of x is equal to 0.05 right here. So to solve for it, we first got to solve for the derivative. So to solve for derivative, first I'll just write this function now just so it's easier. We just apply the general power rule for derivatives. You can see proof of this in the video link below. So use the power rule, drop the 3 down, subtract by 1, so 3x squared. Same thing for this one, 2x, and then this is going to be negative 2, and then this one's going to be 0 derivative of a constant 0. So we have this one right here, so we got to plug in now f prime of 2. Plug that in, it's going to be 3 times 2 squared plus 2 times 2 minus 2. This would equal to, this is 3 times 4. This is 12 plus 4 minus 2. So this would equal to 14. So now our dy is going to be equal to 14 times it by 0.05. And you can plug this in the calculator or just solve it out. This is going to be 0.7. Yeah, so this is 0.7. If we compare, basically, let's go with delta y minus dy. This is going to be equal to 0.7176 minus 0.7, and this equals to basically 0.0176. Yeah, so this is it's pretty similar, but now I'll show you with part B. And I'll show that this number is going to get smaller and smaller. Yeah, so for part B, now we're going from 2 to 2.01, or our dx now is going to be equal to 0.01 right here. And now if we want to get delta y, this equals 2 f of 2.01, and then minus f of 2. So now we got to plug this into the calculator. So yeah, if we plug this into the calculator, we're going to get now, this f of 2.01 is plug this into the function. We're going to get now 9.1407 and etc. So it goes something around there. And now f of 2, we know this is going to be 9. So we basically now we get delta y is equal to 9.1407 minus 9. That's 9 is, yeah, 9 is basically f of 2 right here we solved earlier. So this would be now 0.1407. So now if we want to solve for dy is going to be much easier to solve because we know it's going to be, well, f prime of x dx. And this one here, remember, this is going to be x is equal to 2, is the same thing as before. And d of x is equal to 0.01. That's the only thing that's changed. So we know that dy is going to be equal to 14, because this is going to be, this is just f of 2, f prime of 2. We already solved this one, now we plug in this 0.01. This would equal to now, yeah, if you just plug this in the calculator or just solve this in your head, it's going to be 0.14. So we get this value, compare this now to this one. You could even subtract it, so we get, let's say, delta y is equal to now 0.1407 minus 0.14. This would equal to I made a mistake, I just corrected it. Now delta y minus dy is equal to 0.1407 minus 0.14. This would equal to now 0.007, etc. So we get this one right here. As you see, it's getting smaller and smaller. In fact, it would get smaller and smaller. Compare this to the part A, which is part A, which is over here, 0.0176. And now the difference is basically 0.007. So in this case, we have our delta y is very close to dy right here. Now to get a better understanding of how this function, like how this compares delta y and this dy, and especially why we have, for both cases, we have our dy, in this case 0.14, and then versus delta y 0.1407, why dy is less. If you look at the graph here, this is the graph of this function f of x using Google Graphing Calculator. As you can see at this point 2, if you draw a tangent line across it, so as you go farther out right here, this tangent line is always going to be less than it. So this would be our dy, and then this case is going to be our this is going to be our delta y. Yeah, our delta y right here, and that's why our dy is less than our delta y in this case. And then when you get smaller and smaller, it's going to obviously get closer and closer to each other. And there you go. When it's near this 2, we're going to have basically pretty much the same number, and that's why what we're getting right here. As you get further and further away, we're going to have this separation right here. Anyways, that's all for today. Actually, I want to go over some more notes quickly before I finish this video. Basically, important notes: as dx gets smaller, dy approaches delta y, like I just explained earlier, and also calculating dy is much easier than delta y, as I showed here. Because we already know the derivative here, we just 14 times 0.01, and we don't need to actually solve for f of x. In this case, we just plug this in. We have to use calculator for both times. And basically, yeah, so it's much easier than calculating exactly what delta y is. And in some cases, it is actually impossible to calculate exact values of delta y depending on how complicated the function is. So basically, we would require doing a linear approximation like this. Anyways, that's all for today. If you learned, you could download these exact notes in the link below in the video description. And thanks for watching, and stay tuned for another Math Easy solution.